Now let us discuss about another class of system which is known as invertible and non-invertible systems. Okay, what is meant by invertible and non-invertible systems? A system in which input can be recovered from the output. That means if a system which is backward compatible, we have given an input, produced an output. If we can produce the same input from the output backwards, then such systems are known as invertible systems. Any system in which the output signals cannot be converted back to the input signals, then such systems are known as non-invertible systems. Now let us go into the video and try to understand what are invertible and what are non-invertible systems.
Invertible and non-invertible systems. Consider a system in which the output is given as 2 times the input. For example, if some value at a particular moment is 2 volt, the output will be 4 volt. Because what is the relation between the input and output? The output will be double of the input at that moment. So we can say that this is an amplifier. This is an amplifier. Okay. Now consider another system which performs this operation. What is that? It is producing the half of the output y of t. So it is producing the half of the output y of t. So what happens? This 4 volt will be divided by 2 and you will again get 2 volt. So it is an example of an attenuator. Okay. So we are getting a signal W of t. So if you look carefully, you can see that this W of t is nothing but X of t, which is the starting voltage, that is the 2 volt. Now what happened here is that you are giving a voltage X of t and you are getting a Y of t, that is 2 times the X of t, and you are taking that Y of t as the input and given to another system which is producing a W of t, which is nothing but half of Y of t, right? So because we are taking half, again you are getting the original input X of t. Here the amplification operation, okay, so here the amplification operation performed by this system is cancelled by the attenuation operation performed by this system, right? If such operations are possible, then this system is known as invertible system. So this system is known as invertible system. And the system which perform the opposite operation is known as inverse system. This is the basic idea of invertible system. Now let us go and check another operation that is also a mathematical abstraction, nothing but an accumulator. So what is happening in an accumulator? Here you can see the output y of n is nothing but the sum of x of k, where k varies from minus infinity to n, that is from somewhere in the past to the present value. You have to add all the input. Okay, here you have to perform the sum of all the input values from somewhere in the past to the present value, that is the output. Now if you are performing some other operation in which you are calculating the difference between the current output and the previous output, then you are getting something called W of n. So actually what we are doing here is calculating the input X of n, right? If you can understand it in this way, in January you have deposited 100 rupees, in February you have deposited 200 rupees, in March you have deposited 300 rupees, right? So up to March, if you take the sum, it is 600 rupees, right? Up to February, if you take, it is 300 rupees, because 100 plus 200 is equal to 300 rupees. Now if you take the difference between March, that is y of n, and February, that is y of n minus 1, you can get the investment in March, that is 600 minus 300 is equal to 300 rupees. So that is the investment in March. In order to find the present input, you have to calculate the difference between the present output and the previous output. So what is happening here actually? You have an input x of n, you are giving that to the accumulator. The accumulator will give you the accumulated value or sum. And you are taking that y of n and you are finding out the difference between y of n and previous output, current output and previous output. Then you will get w of n, that is nothing but x of n, that is the current input. Okay. In this case also, you can say that the accumulation operation is, here it is accumulation, okay, or summing operation, okay, and here it is difference, okay, here it is difference. So the accumulation operation is cancelled by the difference operation. So you can get back the original signal x of n, right? In this case, this particular system where this reversing is possible is known as invertible systems. Invertible system. And this system which producing the input from the output is known as inverse system. Inverse system. This is the general definition of an invertible system. You have an x of n, you are giving to the system, you will get a y of n, you are giving to the inverse system. That inverse system will produce x of n from y of n. That is the important point here. The inverse system will produce the input from the output. Okay. The definition is given like this. For a system S, if we can obtain the input x of t back from the corresponding output y of t by some operation, by performing some operation, if you can get back x of t from the output y of t, then the system S is known as invertible system. So this system is invertible system. Invertible system. And this system is inverse system. Inverse system. Okay. So what happens if you connect a system and its inverse system? Here we have a system and that is connected to a inverse system, right? So if you connect like this, whatever input you give will be the output of that system. If you connect two of them in a cascaded manner like this, then whatever inputs you give will be the output, because whatever operation performed by this particular system is reversed in the inverse system. So you will get the final output as the same input. So a system whose output is equal to the input for all possible inputs. So this is very important. This is very important. If it is giving for some inputs, that is not acceptable. For all the inputs, the system should satisfy this condition. Then such systems are called identity system. Now consider another example of a rectifier. Here you can give different kind of sinusoidal waves. Okay, different kind of sinusoidal waves, maybe one frequency, another frequency, maybe a cosine signal, different types of sinusoidal waves you can give. But whatever you give, at the end, finally you are getting a DC signal. You are getting a DC signal. So DC voltage. So this is AC voltage and this is DC voltage. We cannot exactly say which AC signal created this DC signal. That is not possible. For example, this AC signal may create the DC, and a phase shifted signal like this with the same frequency may create that, or a high frequency signal with the same amplitude might have created this, right? So we cannot predict which input signal is responsible for this output signal. So once we obtain this DC voltage, we cannot convert it back to the original input signal. So we cannot obtain the input signals back from the output signal in the case of a rectifier. Hence, rectifier is an example of a non-invertible system. No coming back. Once the signal is converted, we cannot recover it. This is an example of a non-invertible systems. Let us take another mathematical model. Here y of n is equal to 0. Actually the system is taking whatever x of n you give, maybe 1 or 2 or 3 or 5, whatever value you give, this system will make it 0, right? So the function of the system is to create 0 values in the output. So we cannot predict which value resulted in 0. Which value resulted in 0, we cannot predict, right? So this is another example of a non-invertible system. Here is another example. Here y of t is equal to x square t. The relation is squaring here, right? If I give minus 2 volt, this will produce 4. If I give 2 volt, then also it will produce 4 volt. So I cannot predict whether it is minus 2 or plus 2, which one created this output. So I cannot get back the input from the output in this case also. So this is another example of a non-invertible system. Now coming to the formal definition of a non-invertible system. For a system S, if we cannot, see this word is important, if we cannot obtain the input x of t back from the corresponding output y of t by some operation, then the system S is said to be non-invertible. So if we cannot recover the original signal from the output, then that system is known as non-invertible system. I hope it is clear.
I hope you understand the concept of invertible and non-invertible systems. Now, why invertible and non-invertible systems are very important? Consider the case of transmitting a signal through a channel. Whenever we transmit a signal through the channel, there are chances that the signal will be affected due to noise and interference. So when we receive a signal at the receiver end, it will be affected with the noise and we need to recover the signal. If you want to recover the signal from the signal which we received at the receiver end, we need an inverse system so that we can convert the signal which is received or reconstruct the signal back to the original signal. Another one is modulation. When we transmit signal on top of carrier signals as modulated signals, at the receiver end, we are in need of reconstructing the original signal from the modulated signals. In that case also, we need an inverse system to get back our original signals or input signals. Another use of invertible system is in the case of encryption and decryption. When we send some data, most of the time we will encrypt it for security purpose or to check the error. At the receiver side, we must have a system which is an inverse of the transmitter system so that we can revert back and get the original signal by removing the decryption or encryption. So these are all examples of invertible systems. Any system for which the back conversion to the original signal is not possible are known as non-invertible systems. I hope that is clear.